55 million people are living with Alzheimer's disease right now. Every 3 seconds, someone new develops it. Every drug we've tried has failed. For 40 years, we've been fighting the wrong target. But on October 30th, 2025, everything changed. Scientists reversed Alzheimer's. Not slowed it down, reversed it. In mice with advanced Alzheimer's disease, memory came back, learning ability restored, brain damage repaired. And they did it using something smaller than a virus. Nanoparticles that repair your brain from the inside. This isn't another failed drug. This is a completely different approach, and it might actually work in humans. Let's start with the problem. For 40 years, we've tried to cure Alzheimer's the same way. Target the plaques. Alzheimer's brains are full of something called amyloid plaques. These are sticky protein clumps that form between neurons. In the 1980s, scientists found these plaques in every Alzheimer's patient, so they assumed the plaques cause the disease. Makes sense, right? Remove the plaques, cure the disease. Except it didn't work. Drug after drug cleared the plaques beautifully. The plaques disappeared from patient brains, but the patients didn't get better. Some drugs reduced plaques by 70%. Cognition still declined. Memory still faded. Patients still progressed to severe dementia. In 2023, the FDA approved Leqembi, the first anti-amyloid drug. It clears plaques. It slows decline by 4 to 6 months. That's it, 4 to 6 months. After 40 years and billions of dollars, scientists started asking a terrifying question. What if the plaques aren't the cause? What if they're just a symptom? What if we've been attacking the wrong thing this entire time? And then they found something shocking. Some people's brains are full of amyloid plaques, but they never get Alzheimer's. Perfect cognition, no memory loss, and some Alzheimer's patients have very few plaques. So what's actually killing the brain? Your brain has 400 miles of blood vessels, tiny capillaries delivering oxygen and glucose to every neuron. Your brain is 2% of your body weight, but it uses 20% of your oxygen, 20% of your glucose. Every thought you have, every memory you form, requires massive amounts of energy. And that energy comes through blood vessels. In Alzheimer's patients, those blood vessels are dying. The vessel walls become weak. Blood flow decreases. Some vessels close completely. This is called cerebrovascular dysfunction, and it happens before the symptoms start. Here's the key. The vascular damage happens first, 10 to 20 years before memory problems begin, before amyloid plaques form. The blood vessels break down, then the brain starts malfunctioning, then the plaques appear. And when blood vessels fail, the blood-brain barrier breaks. This is your brain's protective shield. It keeps toxins out, keeps the brain environment stable. When it breaks, inflammatory molecules flood in. Your immune system attacks your own brain tissue. Neurons start dying. This triggers massive inflammation. Your brain's immune cells, called microglia, they're supposed to protect neurons. But when the blood vessels fail and inflammation starts, microglia go into overdrive. They start attacking healthy neurons. It's friendly fire. Your brain destroying itself. And with less blood flow, neurons can't get enough energy. They can't clear waste products. They can't communicate properly. Memory formation fails. Decision-making suffers. Personality changes. This is Alzheimer's. Not caused by plaques, caused by dying blood vessels. So for 40 years, we've been treating the symptom. The plaques are just debris. The collateral damage. The real problem is the blood vessels, and you can't fix blood vessels with a drug that clears plaques. Which brings us to October 30th, 2025. A team of scientists published something remarkable. They created nanoparticles. Not drugs, not antibodies. Nanoparticles. These are structures made of molecules that self-assemble, about 100 nanometers across. That's 1,000 times smaller than a human hair. Small enough to travel through blood, small enough to enter the brain. But here's what makes them special. They're programmable. These nanoparticles are designed to find damaged blood vessels in the brain. When they encounter inflammation, when they find areas of vascular breakdown, they activate. Once activated, they do two things. First, they release molecules that reduce inflammation. They calm down those overactive microglia, stop the immune system from attacking brain tissue. Second, they physically support the blood vessel walls. They act like scaffolding, helping damaged vessels maintain their structure, restoring blood flow, repairing the blood-brain barrier. The researchers tested this in mice with advanced Alzheimer's. These weren't early-stage mice. These had severe cognitive deficits, failed memory tests, couldn't learn new tasks, brain tissue extensively damaged, equivalent to humans with moderate to severe Alzheimer's. The nanoparticles were injected intravenously. Just a simple injection. They circulated through the blood, crossed into the brain, found the damaged areas, started repairing. Within weeks, brain inflammation dropped dramatically. Blood vessel function improved, blood flow increased. The blood-brain barrier started repairing itself. And then, the cognition improved. The same mice that failed every test started passing. Memory tests, 80% improvement. Learning new tasks, restored to near normal levels. Spatial navigation, functioning again. This wasn't just slowing decline, this was reversal. Brains that were damaged, getting better. Blood vessel density had increased. Inflammation was dramatically lower. Neurons that were dying had stabilized. Even some neuronal connections that were lost had started regrowing. The brain was healing itself once the blood vessels were fixed. So, when can humans get this treatment? Not immediately. First comes more animal testing. Different doses, different delivery methods, long-term safety. Can these nanoparticles be cleared from the body? Do they cause side effects? Do they accumulate in other organs? This takes 1 to 2 years. Then Phase 1 human trials. 20 to 40 healthy volunteers, testing safety in humans. Not testing if it works, just testing if it's safe. Does it cause inflammation, allergic reactions, unexpected immune responses? This takes another year. Then Phase 2, 50 to 100 Alzheimer's patients. Now we're testing efficacy. Does it actually improve cognition in humans? Does it repair blood vessels like it did in mice? Can we see changes on brain scans, improvements in memory tests, slowing of decline? This takes 2 to 3 years. Then Phase 3 if Phase 2 works. Hundreds or thousands of patients, multiple medical centers, rigorous testing, comparing to placebo, following patients for years. This takes 3 to 5 years. So realistically, if everything goes perfectly, and most trials don't, we're looking at 8 to 10 years, 2033 to 2035, before this treatment could be FDA approved and widely available. That's the honest timeline. But here's what makes this more important than just Alzheimer's. This approach doesn't just target Alzheimer's specific biology. It targets vascular dysfunction, which means it could potentially treat vascular dementia, stroke damage, traumatic brain injury recovery, maybe even Parkinson's disease. Any condition where brain blood vessels are damaged. And it's already changing how researchers think. Labs around the world are now developing their own vascular repair strategies, not just nanoparticles. Some are using gene therapy to strengthen blood vessels. Others are testing stem cells that rebuild the vasculature. The entire field is shifting focus, from plaques to blood vessels, from trying to clear debris to fixing the foundation. For the 55 million people with Alzheimer's today, this won't arrive in time for most. That's the brutal truth. But for the next generation, for people who are 40 or 50 now, who might develop Alzheimer's in 20 years. This could be the treatment that actually works. And here's the bigger shift. If we can detect vascular damage early, before symptoms start, we could treat people preventively, fix the blood vessels before neurons die, stop Alzheimer's before it begins. That's not science fiction. That's the logical next step. October 30th, 2025 will be remembered, not as the day we cured Alzheimer's. We didn't. But as the day we finally understood what Alzheimer's actually is and found a way to attack the real cause. After 40 years of failure, we're finally on the right path.